So we want to label the different rays and angles. So let's start with our normal. So the solid line is like our surface. So like on this, the top part would be the first medium, and then this is going into the second medium. And then this dashed line right here that's perpendicular to the surface, that's going to be our normal. The incident ray is the one that is coming into the surface, the incoming ray. So the only one that's coming in towards the surface is this one right here. So this will be our incident ray. And then these two will be either our reflected or our refracted. So to reflect means to like bounce off. So if this is my surface, the ray that's bouncing off the surface is this one. So this one would be my reflected ray. The one that goes through the surface but is bent, that's this one right here. This is my refracted ray. Okay, and then we also have three angles. Remember, we always measure our angle to the normal. So the angle of incidence is from the incident ray to the normal. So this one would be our angle of incident. And then from the reflected ray to the normal, this one right here, that would be our angle of reflection. And then from the refracted ray to the normal is our angle of refraction. Notice that these two angles are equal, so the angle of incidence will always be equal to the angle of reflection. Your refracting angle is not the same. This is a smaller angle, right? It's going through, and then instead of continuing on the way it was, it bent inwards. It has a smaller angle. So it didn't ask this, but because we are getting a smaller angle on this side, that means that this side it has a bigger n, a bigger index of refraction than the other side. Because the angle got smaller, so that means we're going into a bigger n. Right? What occurs as a ray of light passes into air from water? So that's going from 1.33 and 1.33 into n of 1. So I'm going into a smaller n. If I get a smaller n, then I'm going to have a bigger angle. Smaller n is going to go faster because it's less dense. So this would be increasing in speed. This goes into air from water. It's bending away from the normal, and it's going to refract at a bigger angle. Okay. Sorry, we meant to put multiple answers there. All right, light travels from medium X into medium Y as shown. Which of the following is correct? So I'm going to sketch in my normal. It's perpendicular to the surface. And I'm going to look at this angle compared to this angle. So this one is definitely a smaller angle, which means a bigger n. This one is a bigger angle, which means a smaller n. Smaller n is less dense, and less dense will travel faster. Bigger n is more dense or denser, so it's going to travel slower. So all of like the ideas, now I can just look quickly just by saying like, oh, this is a smaller angle, so bigger n, that's denser and slower. Index of refraction is the same. No, if it was the same, it'd be the same angle, it would just go straight through. Light travels faster in X than Y. Yep, we look at X, we already said that was faster, so yes. Index of refraction is greater in medium X. No, we said the index of refraction n is smaller here, so that's not true. Light travels faster in Y. No, we said it's slower in Y. Medium Y is denser. Yep, we said denser, so B and E are both true. What are the two conditions for total internal reflection to occur? So first, you have to be going from a bigger n to a smaller n. So like going from water into air, that would be an example. And second, your angle of incidence, so the theta angle of incidence, must be greater than the critical angle. Critical angle defined as the angle that makes it refract at 90. If I come in any more than that angle, it'll refract at more than 90, which isn't refracting anymore. That's on the other side, or the same side, that's reflection. And if it does not have total internal reflection, then it will just refract. So think like the n1 sine theta 1 equals n2 sine theta 2. So that would be just like what we were doing the first 2 days, just straight plug in and find the angle. All right, when a light ray moves from air into glass, which has a higher index of refractions, you're going into a bigger n. If you're going into a bigger n, that's going to get you a smaller angle. So an example of this would be I'm coming in like this, and now That's your incoming angle, and now I'm going to get a smaller angle than before. So bigger end, smaller angle. If I'm getting a smaller angle, that is bending in towards the normal, not bending away. Bending away would be if the angle is getting bigger, which would happen if I was going into a smaller end. It helps to literally write out, like, okay, bigger end, that's a smaller angle, and then be like, oh yeah, that's it. Which of the following shows the path going from glass to air to glass again? So this one is going into a smaller end, so that would be getting a bigger angle. And then it's going back to glass, which is a bigger end, so then I'm going to get a smaller angle again. So I want a small angle, getting bigger, and then getting smaller again. So I'm going to sketch in my normal lines here. So this one does not make sense because that would be like reflecting off the normal line. It should be crossing the normal line every single time, so that just does not make sense. There's no case where it would look like this. Here, that would be not really, that would be like coming in at the critical angle. And yeah, this one doesn't really make sense either. So now in between these two, which are like, right, they're coming in, refracting, and then going back the way they came. Now I just need to say, okay, going from glass to air, that's going into a smaller end, so my angle should be getting bigger. So if I look at this angle compared to this angle, this one's actually getting smaller, so that's incorrect, it's B. And so I have a small angle, it gets bigger. And then I have that bigger angle, and it gets smaller again when I go back into the glass, so B makes sense. Which of the following statements are true of total internal reflection? Include all that apply. So it can only occur when light approaches a boundary and is incident into the more dense. So we said that we want to go into a smaller end. Going into a smaller end is going into less dense material, so that is not true. It can only occur when the angle of incidence is greater than the critical angle. Yeah, that's rule 2. It causes a portion of the light to refract and the rest to be reflected. No, it's total internal reflection. It can only reflect. It's too big to refract out, so C is wrong. When TIR occurs, the reflected light follows the law of reflection, meaning it reflects at an equal angle. Yeah, that's true. It's just reflecting like normal, no refraction. If it occurs at the boundary of water and air, the light must be within within water and heading towards air. So I want to go into a smaller end, so going from water into air, that is a smaller end. So yes, that would be like 1.3321. If it occurs at glass and air, then it's possible the light is traveling within air and heading to glass. No, because from air, which is n equals 1, to glass, which is going to be n equals 1 something, I don't know what it is, that would be going into a bigger end, and we need to go into a smaller end. So B, D, and E were all correct. We are going from air into a glass of water. What happens is it passes from the air into the glass. So it's going into a bigger end, so into a bigger end, and then from the glass into water, and then that's into a smaller end. So in the first one, from air to glass, going into the bigger end, that's going to give me a smaller angle. So that's going to be going towards the normal. And then when it goes from glass to water, well, glass going into water, that's a smaller end, so then I'm going to get a bigger angle, which means I'm going away from the normal. So I want it bending towards and then bending away. So that's bending towards, and then the second part from glass to water is bending away. We have light coming into medium X, or from medium X into fused quark. Light travels faster in medium X. So traveling faster in means a smaller n, because it's less dense. So smaller n. So medium X has a smaller n. So let's go ahead and write this. That means that fused quartz has a bigger n. And as they come in, this is my angle of incidence. Well, I know it's going to refract. There's no way where this is possible because it always crosses over the normal. So no matter what, I can cross A off. Now this one, C would only be the answer if the medium above was fused quartz, right? If it's going straight through, that means it's the same N, and that's not the case because light travels faster there. So now I just need to decide, is this going to be a bigger angle or a smaller angle? So if I look, fused quartz, we said this one has a smaller end, so fused quartz has a bigger end, so that means that fused quartz will have a smaller angle. So the only one that shows the angle getting smaller, running in towards the normal, is B, so rate B. Which index of refraction is larger? Which medium or media will light travel fastest in? So let's look. This one has a bigger angle. This one has a smaller angle. So everyone can get there. And then now it's saying, okay, well, what do we know about n? If it's a smaller angle, then that's a bigger n. If it's a bigger angle, then that is a smaller n. So which index of refraction is larger? Well, index of refraction is talking about n, so which one has a bigger n? Well, n2. Which medium will light travel fastest in? Well, it's fastest in the least dense, so the less dense or the smaller n. So we're going to go smaller n, oh, that's n1. Right, I'm going from air through the other one, so I'm going to come into air, first of all, going from air to flint glass, so that's going into a bigger n. So I should be getting a smaller angle for sure. So this one is going like straight up, which doesn't really make sense. Here, the angle is getting smaller, so that checks out. Here it looks like the angle is getting bigger, so that doesn't make sense. Here the angle is getting bigger, so just looking at the first boundary, we're going to pick C, but then we can see glass to water, that would be a smaller n than glass, so that's going to be a bigger angle, which, yes, it's getting bigger. And then here, that's an even smaller n, so I'm getting an even bigger angle, which is what's happening. It's bending away. If it was going straight through, it would look something like this, but it's not. It's bending out away from it, getting a bigger angle. All right, here we are ranking the biggest to smallest index of refraction, so n. So let's just start with the angle. So this one is the smallest angle. For sure, this is a much smaller angle. Now between these two, I wouldn't eyeball like this shape. I would just look at the line. So the line is coming in right here. If it were to continue straight, it would go like this. It's not, it's bent outward, so that's going to be a bigger angle. So this one is the biggest angle. And then this one is like the middle angle or medium angle. Right? Now, it's tempting for people like, largest to smallest. This one's the largest, then this, then this. But what I asked for is not to rank the angles, but to rank the indices of refraction, the n's. So, let's think. The smallest angle is going to be the biggest n. And the biggest angle is actually going to be the smallest n. And then the medium angle would be the medium n. So, biggest to smallest n, well, the biggest n is n3. Medium one would just be n1. And then the smallest n is n2, because the smallest n goes with the biggest angle and vice versa. Now, speed of light from fastest to slowest. Well, fastest is going to be the smallest n, and slowest is going to be the biggest n, because n is just a measure of density. So light travels fastest in air, but it travels slower in oil and even slower in glass or more dense things. So the smallest n, that's going to be our fastest. Biggest n is going to be our slowest, and then medium is going to be in the middle. So fastest would be V1, next fastest would be V2, and then V3. Now I'm just putting V so that we're not saying like N1 is bigger, I'm saying the velocity in medium 1, the velocity in medium 2, the velocity in medium 3. I put this backwards, didn't I? Yep, I did. We said that this one is the slow. Oh, I did. Yes, I did. Fastest, we said, was 2. My bad. 1 was in the middle. Yeah, fastest is this one, and then slowest is 3, and 1 is in the middle. Alright, does a ray of light incident at an angle of 60 degrees from fused quartz to air refract or total internal reflection? So first of all, let's look at our n's. It's going from fused quartz, so n1 would be 1.46 to air, which is 1. So it is going into a smaller n, so that's possible. I just need to know, is this more than my critical angle? So let's find our critical angle. Remember, the definition of critical angle is the angle that makes it refract at 90 degrees. So I'm going to plug in my n's. I'm going to plug in refracting at 9. I'm going to see what angle makes it refract at 9. I'll go ahead and show you guys all of my steps on these. Hopefully it shows up in the video. Alright, so I have 1 sine of 90, and then that's just 1 right here. So 1.46 sine of the angle. So I'm going to divide the 1.46 over. That gives me sine of the critical angle equals 0.68. And now I need to undo sine to get the critical angle. So undo sine, you do second sine or the sine inverse of that number. And that's going to give me 43 degrees. So critical angle is 43 degrees. That's not my answer. That is the critical angle. So let's look. If the critical angle, I'm going into a smaller n, my critical angle is 40 degrees. If I'm coming in at 60 degrees, this, my incoming angle, is more than the critical angle. If it comes in more than the critical angle, that's going to give me total internal reflection. So I'm asking myself those two rules. Am I going into a smaller n? Yes. Find your critical angle. Are you coming in more than critical angle? Yeah, 60 is more than 43, so yes. Yes to both questions, it's TIR. Does a ray of light incident at an angle of 60 degrees from fused cores to water refract? So this is now going from 1.46 to water, which is 1.33. So I am still going into a smaller n, but now I have a different critical angle because it's two different mediums. So very similar to before, I'm going to find the critical angle. Alright, so this, put 1.33 sine of 90 in my calculator. That's going to give me just 1.33. I'm going to need to divide the 1.46 over. Wow, really struggling with the typing right now. Okay, there we go. That gives me sine of the angle equals 0.91. And then again, I need to undo sine, so second sine of this one right here. And that's going to give me 65 degrees. So my critical angle is 65.6 degrees. Again, not my answer, that's my critical angle. So I'm saying, okay, yes, I'm going to a smaller n. I'm coming in at 60. Is that more than my critical angle? No. So not TIR, which means that it just refracts. And it says, if it refracts, find the angle. So now I'm just going to plug in 1.46. I'm coming in at 60 degrees. Going into water, find what the angle of refraction is. Find what angle 2 is. So 1.46 sine of 60 degrees. That's going to give me 1.26 equals 1.33 sine angle 2. Divide the 1.33 over. That gives me 0.95 equals sine of the angle of refraction. Sine inverse, and that gives me angle 2 is 71.9 degrees. So it refracts at, got my answer, refracts at 71.9 degrees. So total internal reflection, again, you're just asking yourself, am I going into a smaller n? Yes for both of these. And find your critical angle. Once you find it, are you coming in more than that? Yes. So TIR, or no, 60 is not more than 65. Oh, that's just refraction. Just plug in, find what angle 2 is. Does a ray of light incident at 50 degrees from flint glass to fused quartz? So now N2 is 1.46 and N1 is flint glass, which is 1.7? Yeah. 1.7. And if it refracts or not. So earlier we were doing I'm going to show you a second way you can think through this. So earlier we were doing the question, okay, is it going into smaller n, which is yes. And then we found the critical angle and said, is it more than that? Yes or no. Now I'm going to show you, okay, I can just plug in 1.7 sine of 50 into 1.46 sine of angle 2. So I'm plugging in to find my angle of refraction. So 1.7 sine of 50, divide the 1.46 over. That gives me 0.89 is sine of the angle. And I can do second sine of this, and I get that my angle of refraction is 63.12 degrees. So yes, it is refracting right here. Now, if I had tried doing that with number 13, if I had just gone straight from 1.46 sine of 60 and divide the 1 over sine inverse of that, you'll see that I get error because it's not possible to get an angle of refraction, so that's total internal reflection. Now, if I had gone straight here, right, we would have gotten 71, we would have known that it refracts. So that's another way. You need to understand both ways because sometimes it's going to ask you questions just based on critical angle. If it's just a straight plug in, does it refract or not, you can plug straight in and say like, oh yeah, I got an angle of refraction, or no, I got error for my angle of refraction. Okay. Light incident at 50 degrees from water to fused quartz, refract or TIR. if it refracts, find it. So water, 1.33, diffused quartz, 1.46. So no matter what angle, this is not going to be total internal reflection. No way, because this is going into a bigger end, and I need to be going into a smaller end. So I'm just going to straight plug in. We know it's going to refract, and now it's just 1.33 sine of 50 equals 1.46 sine of angle 2. 1.33 sine of 50. Divide the 1.46 over, so that gives me 0.697 equals sine of angle 2, second sine, and that's going to refract at 44.25 degrees. When light passes at an angle to the normal from one material into another material in which the speed is lower, okay. So if the speed is lower, that means it's slower. If it's going slower, that's more dense. So that's a bigger N. A bigger N is going to be a smaller angle. So if it's a smaller angle, that is going to, smaller angle would be closer to the normal, so then toward the normal. Sketch what happens to the ray as it strikes the interface between the two media shown. The critical angle is 90 degrees. So by definition, this is the angle that makes it refract at 90 degrees. So if I want to draw what's happening for each of these, well, let's go to 40 degrees. That's the angle that makes it refract at 90. So 90 degrees to the normal would make like a right. So then it would look like that. It would refract at the 90 degree line. If I come in at less than the critical angle, so less than, this one is less than the critical angle, this one is the critical angle, this one is more than the critical angle. Well, we know what happens when you come in at more than the critical angle. That's total internal reflection, so that's just going to reflect. It's too big to go through, it can only reflect, so reflection's easy, it just bounces off like that. And then this one would be 65 degrees. Now less than that, well, if it's less than that, that's not total internal reflection, it just refracts, so it would look something like this. It is going through, it's bending, but it's not all the way at 90 because 40 degrees is the one that makes it 90. More than that, it's reflecting. Less than that, it's just a regular refraction. Alright, going from A into B, what happens to their speed? So I'm going to draw in my normal real quick. So if you look, I'm getting B is a bigger angle. Bigger angle is a smaller N. Smaller N is less dense, so it's going to go faster. So as the waves enter B, they're going to increase in speed. Carbon disulfide is poured into a container made of crown glass. What is the critical angle when it's incident on the glass to liquid? So, liquid to glass. So it's going from the liquid, which I'm guessing is this, because that's not the glass, going into the crown glass. To find the critical angle, well, critical angle is the one that makes it refract at 90 degrees. So now I just plug in my ends. So N1, sine of what angle goes into N2 that will refract at 90. So plug in 1.52 sine of 90, that gives me just 1.52 here. This is 1.63 sine of the angle. I'm going to divide the 1.63 over, and that's going to give me sine of the critical angle equals 0.93. And that's, I need to undo the sign, so undoing sign, that's going to give me critical angle 68.8. Now normally, we get our critical angle and we're usually answering, is this total internal reflection or not? So we'll need to compare. Here, the question was just, what is the critical angle? Well, the angle that makes it refract at 90 is 68.8, so B. It says, if the light ray in glass makes an angle of 30 degrees, what is the angle of the refracted ray? So it's going to refract, right, because I'm coming in at less than the critical angle. So now I'm just plugging in 1.46, coming in at 30 degrees, going into 1.52. What angle will that come out at? What is my angle 2? So, calculator. 1.46 sine of 30, that gives me 0.73. I'm going to divide the 1.52 over. So that gives me 0.48 equals sine of angle 2. And then now I do sine inverse, second sine of that. That gives me angle 2 is 28.7. Did I type something wrong? 1.46 sine of 30. Oh, I'm dumb. Oh my gosh. In glass to the liquid. Read carefully, guys. It's in glass, so I'm starting at the 1.52 sine of 30, going into the liquid, 1.46 sine of the angle. Good thing that was an answer choice, because that would definitely have gotten me. So 1.52 sine of 30 equals 0.76, and then I've got 1.46 sine of the angle, so I'm going to divide the 1.46 over, and that's going to give me 0.52 equals sine of the angle, and now I do second sine, and that gives me 31.4 degrees. Whew. Careful, you guys. Alright, 22. The light ray in air is incident on air to glass, boundary at 45 degrees, and it's refracted in the glass at 30 degrees. What is the index of refraction of the glass? So I'm in air first, so N1 equals 1. This is my incoming angle, this is my angle of refraction, so angle 1 and angle 2. And now I'm looking, what is the angle of refraction of the second substance? So 1 sine of 45 equals N2, which I'm looking for, sine of 30. So 1 sine of 45 equals 0.707 in N2. And then sine of 30, that's just a number. You can put that in your calculator. Sine of 30 is 0.5. So then I have 0.7 equals n times 0.5. So I'm going to divide the 0.5 over. And then 0.707 divided by 0.5 gives me N2 is 1.41, which is D. A beam of light in air is incident at an angle of 35 degrees to the surface of a block of plastic. The first passes through the block and reemerges on the opposite side into air at one angle. So you actually don't need to do math here. So let's say this is my air right here. This is the glass block or whatever. I don't know. Whatever it is, plastic block. And then I'm back in air again. So if I come in at 35 degrees, when I go into the plastic block, that's a bigger end. So it's going to be a smaller angle, something like this. And then when I come back to air, that's going into a smaller end, a bigger angle again. Well, I'm going to get the exact same angle back out because now I'm in air again, so it's just going to be 35. Doesn't matter what it had gone through, because when it comes back into air, it'll be back at the same angle it was in air before. Indices of refraction, so n from biggest to smallest. So it helps, I think, to like kind of draw in the angle measures. Remember, it always goes to the normal. So if you look right here, this is getting bigger, and this one's getting even bigger. So this is the biggest angle, and this one is the smallest angle. Okay, now let's think about biggest angle is actually the smallest n. Smallest angle is the biggest n. Smallest n is the least dense, so that's going to go the fastest. If it's biggest n, that's more dense, this one's going to be the slowest. So ranking indices of refraction from biggest to smallest, that's ranking n. So the biggest n was n3, then n2, and the smallest n was n1. Speed of light, so fastest, that was in medium 1. I'm just going to call that v1, then v2, and then the slowest was in v3. So those are your rankings. A ray of light incident at an angle of 50 degrees is refracted into water. What is the angle of refraction? So it's in air, so N1 is 1, then it goes into water, 1.33. This is angle 1, it's the incident angle. I'm looking for the angle of refraction, theta 2. So now I just plug in 1 sine of 50 equals 1.33 sine of angle 2. 1 sine 50, that's just 0.76. 1.33 sine of angle 2, so I'm going to divide the 1.33 over. That gives me 0.5716 equals sine of theta 2. See my mark? And then now I'm just going to do second sine of that number, and that gives me the angle of refraction is 35 degrees. A ray of light incident at an angle of 45 degrees in flint glass is refracted in water. What is the angle of refraction? So flint glass, that's 1.7. It's coming in at 45 degrees. Going into water, 1.33. Looking for the angle of refraction. So 1.7 sine of 45. 1.2. Divide the 1.33 over. Gives me 0.9. Sine inverse of that is going to give me theta 2 is 64.6 degrees. So that's the angle that it's refracting at. What angle would the incident ray have to be in order to undergo TIR? Well, it'd have to be more than the critical angle. So, that's not enough, right? I want to know what angle would it have to be greater than. So let's find the critical angle. So 1.7 going into water. Critical angle is the angle that comes in that makes it refract at 90. So I plug in 90 for the angle of refraction and see what angle makes it refract at 90. So 1.33 sine of 90, that's just 1.33. Divide the 1.7 over. Second sine to get the critical angle, so it has to be more than, so if your critical angle is 51.47, so it has to be more than 51 degrees. Anything coming in, anything more than 51 degrees will be total internal reflection. This was coming in at 45, that's not more than the critical angle, so it just refracted, it wasn't TIR. Alright, light is moving from barium glass, to barium glass from diamond, so N1 is 2.45. N2 is barium glass 1.6. If the angle of refraction is 50, so that's angle 2 is 50, I want to know the angle of incidence, angle 1. So 2.45 sine of angle 1 equals 1.6 sine of 50. 1.6 sine of 50, that's just 1.22. And then 2.5. So I'm going to divide the 2.5 over. That's going to give me sine of the angle equals 0.5. Sine inverse, that's going to give me the angle, incoming angle was 30 degrees. Light moves from a diamond to an unknown substance. If the angle of incidence, that's angle 1 is 30, angle of refraction, angle 2 is 62. What is the angle, index of refraction for the unknown? So I'm looking for N2 because N1 is just diamond, 2.45. Alright, so 2.45 sine of angle 1 is 30 equals N2 sine of 62. 2.45 sine of 30, put that in your calculator. That's just 1.225 equals N2. Sine of 62 is just a number, so let's put that in. That's 0.88. Now I'm going to divide that 0.88 over. Divided by the 0.88, and that gives me N2 is 1.38. Second question is, which substance does light travel slower in? Well, it travels slower in the bigger N, because the more dense it is, the bigger the N is. And we have the two N's, N1 is the 2.45, N2 is this, so N1 is, or bigger N is the diamond. So it goes slower in the diamond. Light travels from CR39 to flint glass, so N1 is 1.498, flint glass, N2 is 1.7. Angle of refraction, that's angle 2. Looking for angle 1, the incident, so 1.498 sine of angle 1 equals 1.7 sine of, not of theta 2, because I know theta 2, it's 35. Right, so right side can go in your calculator. That's 0.975. Now I'm going to divide the 1.498 over. That's going to cross off this right here when I divide it over. So that gives me sine of angle 1 is 0.65. So then second sine. And that gives me that angle 1 is 40.61 degrees. That's the angle of incidence that would make it refract at 35 degrees. Light travels from water to an unknown liquid. The angle of incidence, so that's angle 1, and the angle of refraction, angle 2. What is the index of refraction? So it's going from water, so N1 is 1.33, and I'm looking for N2. So 1.33 sine of 35 equals into sine of 40. .76 equals sine of 40 is just a number. It's 0.64. So then we just divide the 0.64 over. So that gives us that N2 is equal to 1.186. Which substance is more dense? Well, more dense is just bigger N, because N is pretty much just a measure of how dense it is, which will then be like how slow it is. So then N1 was water, N2 is this, so more dense is 1.33, which is water. Is more dense. So it would go slower from there.